or the connection to the internet. No, because you're getting in.
You can get it on phone if you have.
Yeah. Try your phone. Might be a little bit of a pain in the ass with the sheet, but y'all are young, you can handle that. That kind of shit drives Gen Xers like me crazy. Like, what the f am I supposed to do this? I got fat fingers. How am I supposed to do this? Sorry, no editing today. Okay. Is that still recording? Unfortunately, yes. Okay. All right. You got some numbers? Not everybody at once. 2 standard deviations. What does it say? Oops. What the hell just happened? 2 standard deviations. What does it say?
95.
It rounds to 95%. It's actually really close to 95.5. How many of you started goofing around with the number and tried to get to equal exactly 95? Anybody? There's always somebody. No? Nobody did? Okay, that's fine. We'll come back to it in stats. Hope's like, I'm barely holding on, Sean. I'm barely holding on. Why you gotta ask me stupid ass questions? Number 3. What percentage is within 3? In class last time I said just about all. But you know that's not right because the curve goes on forever. So what percent is within 3 standard deviations, my dear friends? Not everybody wants.
99.73.
Thank you, Hope. 99.73. So those are the ones that are between, what do we say? It was 3.6 pounds and 11.4 pounds. A lot of babies. But there's still some that are outside. And we're going to come back to my preemie student, my 2.3 pound student soon. Towards the end. Maybe in about an hour or so we get done. 4 standard deviations. 99.99. We're punching out. How about 5? I couldn't help myself. How about 5? And I think I gave you a hint. Yep. You need to add some, because it's not 100%. That's BS. It's not 100%. So what do you have to do? You got to make it round a little bit more for you. Let's bump it out a little bit. Look, about 99. If you, how saucy you feel? We'll go to the first 9. Yeah. But even though, and then, now of course, this graph, I stopped it at -4 and 4. There's really no realistic reason to go out further than even 3 in most cases. Because so much of the curve is within 3. That's where most of the stuff happens. But it can handle any number of standard deviations you put into it, mathematically. Because it's doing the math independently of this graph. This graph is just a representation of that mathematics. Fair? Okay. Now here, why give you this sheet? Why can't you just memorize the 68 or the 95 or the 100 or whatever? Because in reality, most stuff happens away from the exact numbers. Most stuff happens away from the exact numbers. Here. I've had that thing for like 3 weeks now. It still scares the shit out of me when it slams like that. Because it sits open for like 15 minutes and then slowly, and then wham, to the cats in the morning. Bottle brush tails. Suppose a newborn weighs 9.2 pounds. We're going back to the baby weights from the warm-up. I gave you the average again and the standard deviation again up top. Average, 7.5 pounds. I also put the Greek letter next to it if you're feeling saucy. That's the Greek letter for the average of the population. It's the Greek letter mu. Also the sound a kitten makes. And the standard deviation, the symbol for that is a little sigma. This came up in class last week. I wanted to make sure. Somebody brought it up, and I forget who it was, and thank you for whoever brought it up. I figured I'd put it back in the notes again. Do you have to memorize it? No, because I'm always going to use the words average and standard deviation because that's more important. Okay, so suppose a newborn weighs 9.2 pounds. Let's do these next 3 together. I want to make sure you understand the process of what we're about to do. How many standard deviations above average is that newborn? So let's see why this is slightly challenging. Let's see why this is slightly challenging. No, damn it! Ooh, wait a minute. Do they line up? Holy shit, they do. Hang on. If I can just scooch up my Google sheet to sit on. No, to hell with it. No! I'll just write them again. Sorry, showing my Gen X roots here. What number goes with that 0, fam? 7.5 pounds. What number goes with that 1, fam?
8.8.
What number goes with that 2, my friends? Where's your 9.2 pound baby? It's somewhere between here and here, yes? I like what you said, Nat. You said in. I just looked at Nat and Nicole. I'm looking back at Nat and talking to Nicole. You said in the middle of 8.8 and 10.1. She doesn't mean exactly in the middle of it, does she?
No.
She doesn't mean exactly. She means between. So the question is, where exactly? Where is it to a tenth? Do you have it, Mariah?
No.
Oh, you don't? Okay, I thought you did. I'm sorry, I misunderstood. Anybody got any ideas? Hold that thought, Elena. I'm gonna kind of scan, because this is definitely something I've never taught you how to do before. So I'm curious. What do you think, Katie?
Well, let me explain this.
Yes, this is not an easy thing to explain, so do your best. It's not trivial. Well, it's actually a pretty straightforward calculation once you got it, but seeing it the first time is not, so explain.
Well, I did like 1.65.
Tell me why.
Because I figured out where 9.2?
Mm-hmm.
9.2 was in between 8.8 and 10.1, and I did like one little notch for each.
Okay.
point.
So let me ask a question. Would 9.2 be closer to 8.8 or closer to 10.1?
8.8.
Forget the bell curve for a second. Just think about the number 9.2. It's going to be closer to 8.8, correct? Does that make sense? Because it's only 0.4 away from here, but it's 0.9 away from here. Does that make sense? Okay, so it's going to be something like, maybe like right about here. Ish. We'll see how good I am when we actually enter the numbers into the calculator in a second. We'll see how close I came to where I put that. Now, what you were saying, Katie, I like what you were saying. I just think you superimposed the numbers.
Okay.
I think. Explain what you did again. Let me hear it.
I think you're right. But
I think.
I
Because the math you said,
I just went like 8.8, 8.9, and went up, and it ended up being like 1.6.
Got it.
I did from 1. So
Got it.
1.
So the thing we have to use here is we have to talk about the standard deviation being 15. That's important. We have to talk about that standard deviation being 15. Why?
Oh yeah, because there's 15 in between 1 and 2.
Right. So why is that number right there equal to 1? Well, because that number, that 1 standard deviation, is 15 divided by 15, which is equal to 1. It's 15 pounds up from, I keep saying 15, Jesus. It's not 15. I'm going back to IQ. I'm sorry. It's 1.3 pounds up. I'm so sorry. My brain shifted back to IQ there from the warm-up, or from the homework. I apologize. It's 1.3 pounds up. So if you're 1.3 pounds above average, that means you're 1 standard deviation, because 1 standard deviation is 1.3 pounds. Sorry. I'm terribly sorry about the 15 there. It snuck in. Why is this one 2? Why is that one 2? Well, it's 2 standard deviations, because that baby is 2.6 pounds above average, correct? And if 1 standard deviation is 1.3, then 2.6 divided by 1.3 is 2. Can we do something similar with the 9.2 pound baby? Elena, I think this is what you were getting at, right? Tell me what you were thinking then. What'd you do with that 9.2 pound baby?
I found its distance from the average.
Uh-huh. How many standard deviations
That's it.
is the 9.2 pound baby? Well, the first thing we did, look, I know we didn't really do it here, but we kind of did it, because we said that this baby here is 1.3 pounds above average, right? How many pounds above average is a 9.2 pound baby? Well, I don't know, but we can figure it out, can't we? We can take that 9.2 pound baby, figure out how high above average that baby is by subtracting off the 7.5. What does that equal, my dear friends?
1.7.
That's 1.7, is it not, Allie? That's 1.7. Which is really, that's where your 1.65 kind of sits right in there, doesn't it? Okay, that's why I think you're right here. So this makes sense to us because it's bigger than 1.3, but not as big as 2.6. And then we gotta turn it into a standard deviation by dividing that by 1.3. Oh! What's 1.7 divided by 1.3? What do you get? You say that again. Oh, it's 1.3. It actually ends up rounding to 1.3. Beautiful. It's about 1.3 standard deviations above average. That's kind of inconvenient actually. I probably should use a better number. So these are all in pounds. 9.2 pounds minus 7.5 pounds is 1.7 pounds divided by 1.3 pounds. This doesn't have a unit. That's just number of standard deviations. That's the z-score, if you will. So that baby, that 9.2 pound baby, is 1.3 pounds above average. What would we say standard deviations above average? Part.
Okay.
Yeah, you buying that, Katie?
Yes.
Okay, good. What percent of babies are within 1.3 standard deviations of the average? Now use your sheet. .3. We know it's going to be bigger than 68%, but less than 95%. Hot damn! How close was my drawing? I'm curious. Where did I put that 9? Was it close? That's not bad! That's where I drew my line. I'm a little bit shy. A little bit shy. But don't worry, it doesn't matter. The computer does a better job than I'll ever do. Trust the computer. Trust the computer. So we know that about 80.6% of babies are within 1 standard deviation of the average. We buying that? Once you have the standard deviations, you just plug them in. It gives you the area. You're never going to read about 80.6% on the internet because it's not a nice number like 1, 2, or 3. It's 1.3 standard deviations. Weird. It's weird. But that's what this computer comes. This is what this calculator comes in here. So a 9.2 pound newborn is heavier than what percent of all newborns?
80.64.
Oh, Mariah, that was a quick no. You shut Ray down pretty quickly there. Damn. That was, holy shit, man. He was taking his breath in after that statement and you shut him down. So I'm gonna, hang on, you two might want to separate a little bit. Ray said 80.64, Mariah said no. So first of all, Ray, I love the 80.64. I'm gonna stick up for you a little bit here. And that's part of it. But why is that not all of it?
Because it's from the 9.2 down.
All the way down. So 80.64 is definitely part of it. We gotta count that. But what else do we have to count? You say that again, Hope.
The rest of it.
We gotta count the rest of it in this tail. Can we figure out what's in that tail? Tell me how, Mariah.
I did the 80% divided by 2 to get that.
Oh, I love that.
And then I did added that.
I love that. It's the same as what you did in my weight in the warm-up.
Yeah.
It's the same thing you did with my weight in the warm-up, wasn't it? So you know that this is 80.6% right here. 80.6. What did I tell you to round off to? Did I tell you to round off to 1/10 of a percent? Nearest whole percent. Want to call it 81%? Make our lives easy? Let's make this 81%. Let's make our lives easy. 81%. Is that cool? Is that okay? Okay, dear friend, I'm going to raise the screen a little bit. I think. Yes, there we go. That's 81%. What's here and here? Together.
19.
You say that again louder.
19%.
Oh, louder.
19%.
That was a little bit louder. but you're a pretty quiet human being, so I'm not gonna pick on you too much. If this is 81, these two have to be 19, yes? But if the 9.2 pound baby is here, this we're not gonna use. Those are kids that are heavier than him. So I just want this piece down here. What's this piece down here? 9.5%, yes? Half of that 19%. Percent wrong. There we go. So, Nicole,
So 90.5.
the 90.5th percentile. I did the math wrong in here. Cross that out. That's not 89.5th percentile. You see the note right underneath that box? I said, so this new word with the 89.5th percentile, you cross that out and you write 90.5. I did the math wrong in my head when I was putting this together. You just figured out. Who's heard of the word percentile before? Anybody? Anybody in the medical field has definitely heard of it. What it means is, it's the percent you're somethinger than. In this case, heavier. So if your kid pops out 9.2 pounds, they're about the 90th percentile. That child is heavier than 90% of all newborns. I'll never forget this, because when Max went to his 2-year-old checkup, he was in the 85th percentile for length, 90th percentile for weight, and 95th percentile for head girth, which is my favorite measure. You stick a ruler around his head. Like, picture my kid at 2 years old. Charlie Brown. Huge ass head, not that tall, and kind of pushy. I love that. I love that. All a percentile is it's the percent you're water than, bigger than. So this baby right here is bigger than 90.5% of other newborns. All right, let's take 5. You're starting to get that look. I think y'all need a break. Let's do some more of these. We're gonna do more, promise. We'll do more, have to. But I think you're getting the hang of it too, but I also think you need a break. And I gotta fix that typo, that pisses me off that I missed that. Apologies. 90.5, not 89.5, Sean. I think I know what happened. I think I didn't round. All right. Legal editing. Yeah, 90.5. See how many more typos I have to put in the day. Leave that there. That's good. All right. All right. Good stuff. I still can't believe how quick Mariah said no to you, right? Amazing. Neat. Even for East Coast timing, that was impressive.
Did you know that?
Did not have
Did you?
wherever individual.
Oh my goodness. Heaven forbid.
Because it was, I graded everything, and what I didn't have was your individual section. Do you remember doing the one, oh shit. I was talking to class. Let's figure something out. That could very easily be, oh, did you partner with somebody?
No.
So you probably in your brain thought, oh, I did the individual part. Because if you partner individually, then you walk out of here.
Yeah.
Shit. All right, we'll figure something out.
My bad.
No, we'll figure something out. That's something I never even thought of before. That potentially could be confusing to this student who doesn't utilize the partner part of the partner part. That made sense, didn't it? That
Sure
makes
did.
No editing, babies. No editing. How many HR violations today so far? Anybody? Stoke level's kind of middling today. Everybody okay? This stuff just pissing me off. It's pissing you off, Ryan, a little bit. That's why I took it out of Ray. No. 80.6%. No.
Yeah.
That's awesome. I love that. That's great.
He knows.
Wait, what?
He knows me well enough.
I know. You two have been sitting next to the back class for a while now.
Yeah.
I know. That's why I didn't think too much of it.
I'll bet it's-
When you come back in, I want you to try the 8-pound baby, which I put over here. When you come back, hi. What you got? Oh yeah. What you?
So, in my map, they also had these things.
Oh, they did.
Their average is 6.8.
Totally fine. I've actually seen conflict. I used the one that I saw the most in all the research that I was looking at, and it's okay if they use
The
it.
newest version is 2003, so I was wondering if they-
Oh, it's possible. It's quite possible because baby weights have done that over the last 100 years.
I was above like 93.
Uh-huh.
I was at that.
You're exactly median. I
But
love
my
that.
little brother was 12 pounds.
Wow.
And my little sister was.
Wow, 12 pounds, and I bet you it's. Are there some 9s after those 9s too? Or is it just 99?
I don't remember. Yeah, I think so. Yeah, he was 12. My sister was 10.
How many siblings you two have?
I don't know.
You have 2, so you chance
There's
2
4.
more.
There's
It's
4.
4. You already got it. I love it.
I'm the only one that's not above 90.
Don't worry about the fact that your other math class has a different average than mine. The important thing is, can we turn those into z-scores? Because if the answer is yes, then it doesn't matter what the average is.
I'm wondering which one's more accurate.
Well, that need. I don't know the answer to that. And I'm not here to argue that. I'm here to teach you how to use a bell curve. Does that make sense? Is that fair?
Yeah, because I did this one using yours.
Good.
But those ones are bigger.
Right, because 6.8 is down, what, a pound almost, right? Or not quite a pound, 0.7 pounds, whatever it is. Yeah, so don't worry. The question I've never gotten an answer from, here, I'll show you real quick. This is a chart I used to use in my stats classes until I realized that nobody really seems to like it. These are amazing. Oh, yeah. These are incredible charts.
Yeah, we use little, we couldn't make sure.
Oh yeah, I love that. So these are
About that?
so this puppy dog right here is, these are percentile charts. It's a terrible scan, sorry. But you got length and weight on the same chart. So you got birth right here. That is supposed to be the average. Say that again.
Is that line bigger or bigger?
It's bigger because it's median. It's the average. So what they did was they put, I believe that's the 90, yeah, here's the 90, here's the 5th percentile and the 95th percentile and the median. And if you look at where the median is, it's just about 8 pounds, so it's closer to my 7.5. So I think my 7.5 might be more representative of what's actually going on in the world right now. It's not 2009, but it's the one, unless Wikipedia is not being updated constantly, which I think it is. I mean, freaks like you're constantly looking for most recent things. I do believe we're probably going to get quite a bit of agreement.
There
Let's
are
just look real quick. We can buy one for $25.
Yeah.
I can't trust that. But the point being though is, I'm not worried about arguing over what's the correct average. I'm arguing, can we take those and convert them to percentages? That's what I care about. There we go.
You said he's grounded there for 3 days.
What's up, Ashton? Oh, good. Can you what? You can turn it in the next class. You don't have to turn it right now if you don't want to.
Today.
What's that?
As long as it doesn't take too much time. I'll do it today.
Yeah, bring it back next time. Bring it back on Wednesday.
I just have chemistry right after then, so.
No, these are not. what I tell my students about the correction coupons, and you might remember this from Math 98, you can wait till the end of the term too, and then do it all at once. Now, if you lost, say, 5 points on the exam, and you want those 5 points back, there's no reason to wait, just get them back now.
And can we do, I know last term, we were able to fix our partner cards.
Yes, and where the hell did I put those? I had those clipped. I had them separate. Hang on, I gotta find those. Individual part. Where did I put the partner parts? They must have fallen. Yes, I've got them. I kept them separate. I didn't staple those in because they were partner parts. I'll find them after class. Stop me after class. They're in this pile somewhere. Are we getting some numbers for our 8-pound baby? Let me shut down some of these windows and get the Google Sheet. There we go. 8-pound baby. How many standard deviations?
I got 25.
Ray got 0.5. Who wants to argue with Ray besides Mariah? 0.4? Okay, maybe we're arguing about 0.8. Okay, we're getting all kinds of numbers. I love this. This is friggin' awesome. I love this already. Okay, here we go. Let's just figure it out. Is this baby above or below average? Let's start there. Above average, because above 7.5 pounds, right? Thank you. So, I'm going to change the bell curve to baby weights. 7.5 pounds. One standard deviation would be 8.8 pounds, right? So we know this baby's between those two numbers. I'll be somewhere around, maybe here. 8 pounds. How can we figure out? Let's think about what we did last time. What did we do last time? First thing we figured was what? Say it again.
How far from the average?
Oh, how far from the average? I'll be your voice. How far is that baby from the average? Say it loud, say it proud.
0.5.
0.5 pounds, thank you, Cole. So step one is find out how far from average. How far from the average? So we take the baby weight minus the average weight. So baby minus average. I'm going to use that symbol if that's okay. Can I use mu? That's the symbol for average. Just get used to it. 8 pounds minus 7.5 pounds equals 0.5 pounds. Half a pound above average. Fair? Okay. And that's great. Except we need to know how many standard deviations above average they are, because that's what bell curves all share in common, standard deviation. So what do we do with that? I just heard somebody go, so what do we do? You say it again, Keely. Divide that by 1.3 pounds. So take that and divide step 1 by the standard deviation, which is that funny little weird sideways 6 looking thing. So we take that 0.5 pounds divided by 1.3 pounds. What do you get?
0.38.
0.38? Let's call that 0.4. How about we call that 0.4? Is that okay? 0.4 standard deviations. And that, my dear friends, is a number we can use in our calculator. Because my calculator, I didn't program my calculator for baby weights. I apologize. You know why I didn't program for baby weights? Because what if we then shift to IQ? And then what if we shift to VO2 max? And then what if we shift to anything else that's bell curved? Like Plinko results. Then you gotta make a new spreadsheet every time. So I said, instead, I just teach them this math. And then we can always use this calculator. Just FYI, I put a formula in the footnote of your notes. You just did this. This is literally what you just did. But it's a formula in math. It's called a z-score formula. You just did that. So you just did it in 2 steps. This is just only 1 step. Cool, cool, cool? All right, so that baby is 0.4 standard deviations above average. Bless you all. What percent of babies are within that many standard deviations? You say that again louder. I got 31%. Is that what we all got? I love that. Look how narrow that is.
I got 30.
Yeah, I got 32.
It was 29.6.
Did you put in 0.38? That's probably the difference. Oh, and I'm never going to get into a fist fight with you about this. I am never going to get into a fist fight with you about this. If you put in 0.38 standard deviations, you're going to get a slightly different percentage. If you put in the exact, I'm curious now. Can I put in something real quick just because I feel like a dork? What I'm doing right now is I'm actually typing the formula in that you did. I still get 30 because it rounds off to 0.4. So I'm not going to get into a fist fight, Hope, with you, unless you kick my ass. I'm never going to get into a fist fight with you because depending on what you round off to, you just saw can make a slight difference. But how far were we off from each other? Exactly, 1 percentage point. We're not going to get into a fist fight about that. Okay. Like I said, you kicked my ass. Okay. So now we know that about 31, and even though that's super narrow, that's about 1 out of every 3 babies. Isn't that crazy? That's about 1 out of every 3 babies. I love how this curve is so, it's such a mind-blowing thing because of its shape. It hides its areas really well, and anyway, we'll come back to that. Okay. 8-pound newborn is heavier than what percent newborns?
65.5.
How dare you? You want to yell at him again, Mariah, or no? He did it right that time? You like that one? That's good. That's good. I love that you two can have that relationship. Makes me happy. I'll let you know when you're wrong and also celebrate you when you're right. You should all hope to have friends like that. Explain yourself. I know, right? Explain yourself, Ray. Ray is eating. Let's not have Ray choke himself. Explain where Ray got his 65% from. Anybody want to jump in and tell me where he got 65% from?
I can jump in.
Are you sure? You gotta swallow that food. I don't want you choking. I don't know the Heimlich. Well, we got pre-nursing students. We know the Heimlich. Okay, Ray, go. Try the die.
So I took 100.
Yes, you did.
I subtracted 31
Oh God, I love this.
to get 69.
I love this. I love this. So we know that this area is 31% because the calculator just did that math for us. Ray said he took that away from 100%, which I also love, to get 69%. Where's that, Ray?
Where's what?
Where's 69% on the curve?
Either side of the.
Here and here. But somebody just said but. Hope, go. Aha! The 8-pound baby is only going to be heavier than these babies. So we have to figure out what that part is. So if both of those are 69%, one of them is going to be half of that, right? What's that going to be, 34 and a half?
Yep.
Did I do that right? Now this is also 34 and a half over here, but we don't need that one for this problem. Love it. So he's or she, whatever this baby is, 31 plus 34, I get 64.5 or 65%. I love that. This baby is heavier than 2/3 of babies. 65th percentile. Katie, what's on your mind right now? You good?
Yeah, I just do it a different way.
No, tell me how you did it. May I? I love this.
Well,
Did you cut 31 in half and then add to 50? Oh, you badass. Who else is doing it? Amelia, you doing that? Who's doing that? I love that. Oh, my God. I love that 4 of you are doing that. So what the other 4 of you are doing is you get that 31%. Cut that in half to get 15.5%. Did I do that right? Yeah, 15.5. Then add that to half, which is below average. See? There's always going to be multiple ways to solve these problems. I love it. Ray, she's right. Don't quit. I love it, I love it, I love it. We good? God, that was cool. Thank you for bringing that in, Katie. And thank you for having that, because that face said, something's not sitting quite right. But it was. It was just like, I solved this differently. No, I solved this differently. But it's cool, because you're solving it correctly, too. You're doing the same math in a different way. Okay, and I said we call that the 65.5th percentile. Did I do that math right? Is that what we got, 65.5? Okay, I did that one right. Or heavier than about 2/3 of all babies. Yay. Okay. Now, what happens if a data point is below average? Okay, where are these together? What happens? Well, nothing. We just have to deal with it. Suppose a newborn weighs 6.5 pounds. Below average, right? Okay. How many standard deviations below average is that newborn? Go ahead, try to work this one out. Actually, try to work 12 out by yourself, and then we'll regroup and we'll make peace with it. Add some images to this picture over here. 6.2. What kind of z-score is this baby going to have? Don't tell me the number. Tell me the sign. Technically a negative one, right? Because they're below average. You don't have to sweat that too much. You don't have to sweat that too much because my calculator takes care of negatives as if they were positive. It didn't. But how many standard deviations down are they? You got a number for me?
Negative 0.8.
Negative 0.8, about 0.8 standard deviations. Ray likes that one. Okay, give me a thumbs up if we like that one. Let's recalculate. Let's calculate. I definitely want to calculate it together. Do you want to use the z-score formula to see how it works? Or do you like doing it step 1, step 2? What do you like better? You want to see a formula, which is effectively steps 1 and step 2 together? Or do you want to just do it step 1 and step 2? Nicole, you vote. Step 1, step 2. Let's do it, baby. Let's do it. Step 1 and step 2. So step 1, the baby's difference from average. Baby is 6.5 pounds. Subtract the average, which is 7.5 pounds. So that's a negative 1 pound difference. I'm going to stop us right here and step away from the problem and then step back into it. Is a negative 1 pound difference, is a 1 pound low difference meaningful in every situation? Not just baby weights, but any situation. Is being 1 pound different meaningful in every situation? No. It depends on the context, right? I will lose and gain somewhere around 2 or 3 or maybe even 4 pounds today, depending on how much fluid I'm putting in me. We talk about water weighing 2 pounds a quart. I drink a lot more than that a day, but then I pee and I sweat and I expirate water vapor. So we, as adults, lose pounds and gain pounds every day. But with a baby, it is meaningful, right? So how do you mathematically express that? With step 2, you have to put that 1 pound down in divide 1 by the standard deviation. You got to put it in context. So you take that negative 1 pound, and you divide it by that 1.3 pounds, and this tells you how unusual it actually is. It takes the units away and puts it on the bell curve. Is that where we get our 0.8 from? Negative 1 divided by 1.3? Awesome. 0.8 standard deviations. Now technically it's negative. It's negative because we're down. And this is, I put an apology on page 1 of your notes. Or maybe it was in the warm-up. I forget where it was now. I put an apology about how many different things we use the phrase standard deviation for. Like, for example, that is the standard deviation. This is a range that is standard deviations, and this baby is negative 0.8 standard deviations from average. Those 3 different, I know, Nate. I know, man. I know, and I apologize for all statisticians. I wish they named them 3 different things, but they didn't. But that's okay, we're making peace with it. We're making peace with it. Okay? Now, what percent of babies are within that many standard deviations? I didn't actually ask this in number 13. But what percent of babies are actually within that many standard deviations? Well, 0.8 is 58% of them. So what percentile is our little 6.5 pound baby? Can we solve this the same way we did the last couple? Depending on how you did the last couple, you can. Kind of, can't you? Sort of, kind of. But we can't do it exactly the same. What we did last time was fairly straightforward. Here's what we did last time. Here's what we did last time. We said, okay, this is 58%, right? So Ray says take that away from 100%, which would be 42%. 42% is here. That means this is 21. This right here is 21%, yes? Fair. Then we add that 21 to that 58. Why does that not give us the percentile for a 6.5 pound baby? Mariah? Because the 6.5 pound baby is here. This would be an 8.5 pound baby over there. 1 pound above, not 1 pound below. So your job is actually much easier now, isn't it? What percent is a 6.5 pound baby heavier than? You say that louder, whoever that was. Who was that? I just heard very quiet. No, nobody? Okay, let's go. Oh, Amelia, I gotta get your voice. No, it's Keely! Keely, what is it? 21%. 21%. Look. If the 6.5 pound baby is here, that baby is heavier than this tail, correct? And that's all they're heavier than. They're not heavier than this. They're at the bottom end of this. Right? So no, we can't do it like we did before. It's easier than what we did before. They're just heavier than the tail. They're at the light end of the standard deviation, not at the heavy end anymore, so you don't have to add in the rest of the standard deviation. Nicole, ask me that question, or does that make sense? That makes sense. Okay, good. I couldn't read your face. I couldn't tell if it was like an upset because your head went to the side and then your eyes changed, and I was just kind of in the dark over there and I couldn't tell. Sorry. When Chanel's here, she just yells at me. And, you know, hi Chanel, treasure you, just so you know. So yes, 21%. So this is 58%. That means these two are both 21. And the baby is only heavier than this tail right here. So yeah, you can't do it like you did the previous ones. It's actually easier than the previous ones. Yay!
Right now, I'm just talking
That's right, Ray. Tell me again, brother. Tell me again. Whatever you just said. I love it. Whatever you just said. Oh, I thought you were. Never mind. Hope, question, comment.
Oh, I got 56% because I did.
Tell me how.
I didn't round the 8. I did 0.77.
Oh, so your 58 is not 0.58. It's point. Oh. Again, we're not going to get in a fist fight about this, girl. We are not going to get a fist fight about this. Yes. Depending on what you round to is going to determine what that percentage is. Right? I talked about this with when Max had his two-year checkup when I got the 95% head girth. I didn't know what the numbers they were using was. They just gave me the percentiles, and they sent Jen home with this sheet where they had filled out a big dot where his weight was, but the dot was drawn so big I couldn't tell exactly where it was. I'm like, this could be 10 pounds, this could be 10.2 pounds, this could be 9.8 pounds. And Jen actually asked the PA that and said, what is it? And she's like, well, why does it matter? And then my wife, who's smart as a whip, was like, because that could be a difference from, the 60th percentile to the 80th percentile. And the PA was just like, what are you talking about? And Jen was like, never mind, that's my husband. And then I realized, I'm like, wow, people don't always understand these curves. They put things on charts and hand them off. But that's why I want it to be part of Math 105. This is useful stuff. This is actually, it's not just baby weights. We're going to shift to something else here in a second. But so many things are bell curved that you could do so much with these bell curves. Fair? Okay. Anybody else? Questions, comments before we move on? You buying this? Hopefully. Maybe. Maybe a little bit. We're getting there. Here's my student from the warm-up. Remember we figured out she was 4 standard deviations below average? Now this number should look familiar to you from, I had you do this back on page 1. I had you plug in 4 standard deviations to see what that worked out to be. And it was 99.994% of babies are within 4. Now follow that last paragraph at the bottom. Since 99.994% of babies are within, 0.006 are in the 2 tails, correct? Whatever's left, Ray, minus 100%, right? Or from 100%, thank you, sir. Then I took half of that because half are on the left side. So she is the 0.003 percentile, which means she's actually heavier than some babies, which blew my, I mean, 1 in 33,000, but still, she's heavier than 1 every, and how many babies are born? What's a baby born every 6 seconds, 7 seconds, something like that? So she ends up being heavier than a few babies born every month, which is mind-boggling. 2.3 pounds, Jesus. Hope's like, could you please stop talking about babies and getting excited about it? Okay, we'll stop talking about babies. Who's sick talking about babies? Stop talking about babies? Okay. We'll talk about women's heights in the homework. How's that? Is that okay? Oh boy, man. How much sauce today? It's all right. Wait for Cynthia. She must stab me in the heart with that pencil. Okay. Doctors, I brought this up earlier. Doctors often refer to percentiles when talking about health stuff. I didn't know how to phrase that, so I just called it health stuff.